Now let's talk about sliding window technique, what it is and how do we use it. So let's take a motivation problem that we are given an array of size n, and what we have to do, we have to print sum of all sub arrays of size k. So what essentially we have to do, let's say this is an array that is given to us, and what we have to do if we are given the window size k, let's say an example here, let's take k as 4. So what we want to do, all subarrays of size 4, we want to print their sum. So sum of first subarray is, let's say 10 plus 4, 14, 115 and 2, 17. So we know sum of first subarray is 17. Same way we have to look at the second subarray. So we know the sum of this is going to be 4 plus 2, 6, 10, 16 and 23 is 39. Same way, if we see for every sub array, we want to print the sum. So this is the expected output. Given an array and given window size k, we have to print the sum of every sub array of size k. Now, if we have to solve this problem, then what we can do is we can go with a brute force approach where we can consider every sub array of size 4 and then we can calculate the sum. So let's take a look at the brute force code. So what we have is we have to write a function print k window sum. So we have array, we have size of the array, and we have k, which is window size. Now, if we write a separate function, let's say get window sum, the responsibility of this function is if we give the start index. So if I say 0, it should start at 0th index and give me sum of k window elements. So it will go from 0, 1, 2, 3. It will add all 4 elements if k is 3, and it will give me that sum back, right? So if that is the case, then what we can do, we can say like start with I is starting with start and I will end at k plus start minus 1. So ideally just see if my window size is 4, then my starting should be at 0 if I'm passing start as 0, and my ending should be at 3 because 0, 1, 2, 3, this is the window size 4. So this way, this function can calculate sum of any given window if we just tell the start index. Now what we can do, we can call this function for every subarray, and we know there are total n minus k plus 1 subarrays of size k. So what we will do, we'll call this function from start varying from 0 and start going up to n minus k. So we keep calling this function for every possible start value. So first subarray starts at 0 index, we get the sum. Then subarray starts at 1 index, we get the sum of that subarray. Then next, then next. So this way we can go and code. So this is a brute force approach. If you try to look at what is the time complexity of this, then we understand like this function is executing, this loop is executing n minus k times, or we can say n minus k plus 1 times. So starting with 0 and going up to n minus k. And internally this is calling a function, and this function always runs k times. So we can see that this is n minus k plus 1, ideally it should be, into k. So overall complexity, if we leave the term k, it will come out to be n into k. So this is the brute force time complexity. Now, if we solve this problem using sliding window, then we will be able to do this problem in n time complexity. So that is what we are going to see next. What is sliding window and how do we apply that to solve this problem? So let's understand what optimization we are bringing in with sliding window. So sliding window says, let's take a window of size k that is given to us, and here in this example k is 4. So first we calculate sum of these 4 elements. So we know it is 1 plus 4, 5 to 7 and 10, 17. So once we have this window sum, if we want to calculate the sum of next window, which is represented by this blue bracket, then what essentially is changing, these 3 elements are actually common in both the windows. So I can calculate the sum of the next window easily if I subtract 1 from the previous window sum and add 23 to it, right? Because 1 is going out in the next window and 23 is coming in. So if we use this technique, this is called sliding window. We will keep shifting this window, keep removing the last element which is going out and keep taking the new element which is coming in. So let's take a look at how the code will look like now. So this is the same function. We take current sum. So what we do, we first calculate sum of the first window. So current sum, we calculate the sum of first window going from 0 to I less than k, and we are adding that to current sum. So once this loop gets over, we will have the first window sum, which we can directly print, right? Now, Our next window begins at index 1, right? So I'll vary a loop. Start is 1 to less than equal to n minus k. So we are going to every sub window where start is varying. Now, how we get the sum of next window whose start point is index 1? So we do current sum is equal to current sum minus a of start minus 1, because now if start is 1, we subtract this 1. So we are subtracting a of 0, and what we are adding is start plus k minus 1. That is what we are going to add to this. So that means this element will get added here, right? So with that, what we will do, we will get the sum of actually the next window. Now, once we have got the next window sum, we can simply print that sum, and then we can do start plus plus, and this way we can continue to find every window sum. So this is sliding window. Now let's take a look at what is the time complexity of this code. Time complexity wise, if we see first loop that we are running here, this is running k times, and then second loop is going to run n minus k times. So we see this is k, which is one loop, then another loop which is sequential loop. So in sequential loop we add the time complexity, so it's k, and this is n minus k. So k plus n minus k we know is n, because this line has become big O of 1 for calculating the sum of the next window. So this is the sliding window technique, and we apply this to solve many more problems. There are many variations of sliding window, and we will see those examples, those exercises, those assignments next.